In this video, we're going to go through projectile motion formulae. So let's take a question. A particle is projected from a point with speed u at an angle of elevation alpha and moves freely under gravity. When the particle has moved a horizontal distance of x, its height above the point of projection is y. Part A. Show that y equals x tan alpha minus gx squared over 2u squared times 1 plus tan squared alpha. So let's deal with the first part of the question. So what we ought to do first of all is to draw a diagram. So we're going to draw a diagram here. So we're going to first of all draw the vertical part of the plane, then draw the horizontal part of the plane, like so. Now we're going to draw in our velocity vector, say like that, and then we're going to draw in our projectile motion now. So let's do that here. So now we've got our projectile motion, we can say that the angle involved here is alpha. So now what we need to do is also put in the speed, which is u, meters per second. Now what we're going to do is we're going to draw in our vectors for the horizontal and vertical components of the velocity. Just here, maybe slightly over here. We can make a bit more clearer. So from here goes up. So we've got our components. So we can write in our components now, so it's u cos alpha, u sin alpha. So now if we take the vertical displacement here to be, call it y, and we're going to call the corresponding horizontal component displacement x. So it's clear. And for consistency, we can write meters there. So y and x. So I'm just going to eradicate the meters, so we just leave it as x and y, but the units of displacement is meters. So what we're going to do is take the horizontal motion first, and so taking the horizontal motion, we can say that S equals ut. So in our case, x is equal to u cos alpha multiplied by t. Therefore, the time of flight is x divided by u cos alpha. Now, taking the vertical components, we can do the following as follows. So taking upwards as positive, we can do a suvat. Now we know that a is minus g, u is u sin alpha. Now s we said was y, and we know what time of flight is x divided by u cos alpha. So we're going to write that in. U cos alpha. Now, if we now write S is ut plus a half at squared, we now know that y is u sine alpha multiplied by the following, x over u cos alpha, because that's t, minus g over 2 times t squared. So that's x over u cos alpha all squared there. Well, the two u's will cancel out. So this u and this u cancel. And what we end up with now is as follows. We get y is x. Now sine alpha over cos alpha is tan alpha. Minus g over 2. X squared. Now don't forget we need to also square the denominator. So u squared cos squared alpha. Now we almost have what they want, but we should know from trigonometry that we could rewrite 1 over cos as sec of x. So we could write that as x tan alpha minus g x squared over 2u squared. Now I'm just going to write this out in long form as 1 over cos squared alpha. So now you can recognize that's the same thing as sec squared alpha. So just for clarity, so you can see what's happening. So x tan alpha minus g x squared over 2 u squared times sec squared alpha. Well, from trigonometry, from regular A level, there's an identity that says that sec squared x is the same as 1 plus tan squared x. So we're going to replace sec squared alpha with that. So x, improve the clarity of my x there, x tan alpha minus g x squared over 2u squared times 1 plus tan squared alpha is what's required. Now part B of the question states the following. A particle is projected from a point O on a horizontal plane with speed 28 meters per second at an angle of elevation of alpha. The particle passes through a point B, which is at a horizontal distance of 32 meters from O and at a height of 8 meters above the plane. Find the two possible values of alpha given your answers to the nearest degree. So what that means is that the speed u is 28, the value of x is the horizontal displacement, which is 32, and the vertical displacement y will be 8. So let's write those values in, and then we can substitute it into our equation here. Now, pay heed here, in exam questions, they normally do that to say derive this value of y, and then you could substitute those corresponding values in to find its resulting displacement. So it is quite a common question that comes up in exam questions very often. So let's write in our values. So we could say that this is part B here. U is 28, followed by x is 32, followed by that y is 8, and that g is 9.8. Now, what we can do is then say, well, y in our case is 8, x is 32, tan alpha minus g times 32 squared over 2 times the value of u, which is 28 all squared. And so make our 8 a bit more clearer. Then we have 1 plus tan squared alpha. So what I'm going to do now is I'm going to say 8 is 32 tan alpha. Now I'm just going to type that straight into my calculator to get a numerical value. So 9.8 times 32 squared over 2 times 28 squared. And that gives me 6.4. So I get 6.4 times 1 plus tan squared alpha. So what that gives me is I get 8 is equal to 32 tan alpha minus 6.4 minus 6.4 tan squared alpha. And then we can solve our equation. So we're going to get 6.4 tan squared alpha, then minus 32 tan alpha, plus 8 plus 6.4 equals 0. So we can simplify our quadratic down to be 6.4 tan squared alpha minus 32 tan alpha. So that gives me 14. So plus 14.4 equals to 0. And then we can just type that onto our calculator using the polynomial equation function. So our coefficients are 6.4 minus 32 and positive 14.4. And when we do that, we get the following values. That tan alpha is, let's do it in order of magnitude, the 9/2 and a half. So we get a half, and tan alpha is 9/2. And if we do tan inverse of both of those values, or arctan, we're going to get that to the nearest degree, alpha is 27 degrees, and that alpha is 77 degrees to the nearest degree. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So let's read the question. A particle is projected from a point with speed 21 meters per second at an angle of elevation of alpha and moves freely under gravity when the particle has moved a horizontal distance x meters. Its height above the point of projection is y meters. Show that y is x tan alpha minus x squared over 90 cos squared alpha. And part B, given that y equals 8.1 and when x is 36, find the values of tan alpha. So, like in the previous example, we're going to start off by drawing a diagram. So let's do that. So we're going to draw in the vertical aspect of the displacement, its corresponding horizontal component displacement, drawing the velocity, and then we can draw in our projectile we did last time. Let's be consistent this time and just follow it in green, exactly the same as what we did last time. This is our projectile motion. So y represents the vertical displacement and x represents the corresponding horizontal displacements. Now they tell us in the question that u is 21, so we could write that in. So we've got 21 meters per second, and the angle of elevation above the horizontal is going to be alpha. So we can draw in alpha here. So that's alpha. We need to split our speed into its horizontal and vertical components. So now we need to resolve the 21 meters per second, or the velocity, into its horizontal and vertical components respectively. So let's do the horizontal. So we do that in pink here and do the vertical. So let's resolve it. So it's going to be 21 cos alpha and 21 sin alpha respectively. So now taking the horizontal motion, we can say S equals ut. So now taking the horizontal motion, s equals ut, we can say x is 21 cos alpha t. T is x over 21 cos alpha. Now we can substitute that into the vertical motion. So let's just do that here. So we're going to do a suvat taking upwards as positive. So we got a suvat. So a is minus g. Now t is going to be x divided by 21 cos alpha. And we've got u is 21 sine alpha, and hence s is y. So now we can use the suvat formula, s equals ut plus a half at squared. So in our case, y is going to be 21 sine alpha times x over 21 cos alpha minus g over 2 times, we got to square t, so it's going to be x squared over 21 squared times cos squared alpha. Now notice, in the final form that they want in this particular question, they want it as y equals x tan alpha minus x squared over 90 cos squared alpha. So we need to get a 1 over 90 here. So if you can't see it, I'm going to write that in. That's a 1 here, 1 over 90. So if I type the following in, so let's simplify this down a little bit. So 21 and 21 cancel. So I get y equals x sine over cos is tan alpha. Now I'm going to write this as follows: g x squared times 2 times 21 all squared, all over cos squared alpha. Now what I was alluding to before was, if I now type these values into my calculator, which I'm going to do on the screen here. So if I now type in 9.8, which is g, over 2 times 21 squared, it should give me 1 over 90, and it does. So we get 1 over 90. So I can rewrite that as y equals to x tan alpha minus 1 over 90, and I'll put x squared here, and I'm going to write this as 1 over cos squared alpha, because that's what it is. And because of that, I get the following: y equals to x tan alpha minus 90 cos squared alpha, and we need an x squared on the top, and that is exactly what they're looking for. Now part B says, given that y equals 8.1 when x is 36, find the values of tan alpha. So we're going to substitute y equals 8.1 and x equals 36 into our equation. So we said y was 8.1, so let's substitute that in for part B here. So for part B, 8.1 is going to be equal to 36 tan alpha minus 36 squared over 90 cos squared alpha. Now we said 1 over cos squared is the same as sec squared, so I'm going to write that as 8.1 equals 36 tan alpha. Now what I'm going to do, I'm going to write it as 36 squared over 90 times 1 over cos squared alpha. And that now will give me the following here: 8.1 equals 36 tan alpha. Now let's use our calculator to simplify that down. So 36 squared over 90 is 72 over 5. Now that's the same as sec squared alpha. Now we're going to replace that with 1 plus tan squared alpha. So that's going to be 8.1 is 36 tan alpha minus 72 over 5, 1 plus tan squared alpha. So if we write 72 over 5 as a decimal, that's 14.4. So we're going to write that as 8.1 equals 36 tan alpha. And we said it was 14.4. 1 plus tan squared alpha. And that gives me follows here. 8.1 equals 36 tan alpha minus 14.4 minus 14.4 tan squared alpha. So I get 14.4 tan squared alpha minus 36 tan alpha plus 8.1 plus 14.4 equals 0. Simplifying our quadratic down, we're going to get 14.4 for the clarity of my handwriting. 14.4 tan squared alpha minus 36 tan alpha. So we're going to get 8.1 plus 14.4. And we're going to use our calculator to solve that. So that's 22.5 equals to 0. And if we type these coefficients into our calculator to solve the quadratic using the polynomial solver, so what do we get now? We get 14.4. Then we're going to get minus 36, 22.5. And we get, it seems to be, we get a repeated solution for tan alpha. So therefore, tan alpha is 5 over 4. And that is the end of the question.